My topic is the isolation of the anti-PCSK9 nanobody from the yeast library to reduce the LDL cholesterol for the treatment of the dyslipidemia. Here is the figure represent the mechanism that our body uses for reduce the LDL inside the bloodstream. The molecule, the purple white shaped molecule represent the LDLR or the LDL receptor, normally used for binding with the LDL, and then they will trigger the internalization process, and the liver cell will degrade the LDL from bloodstream, while the LDL receptor will recycling back to use for reduce the LDL again. On the other hand, the PCSK9 is the protein that used for suppress the LDL activity. If the PCSK9 bind with the LDL receptor, it will trigger the internalization process. But in this case, all of the molecules, including the PCSK9, LDL, and the LDL receptor, are all degraded inside the liver cell. This means that if the PCSK9 gain off function, we will lose the 2 or the LDL that used for reduce the lipid in the bloodstream. In our project, I'm trying to explain the VHS domain or the variable region of the antibody, which is contained the smaller size than the conventional antibody around 10 times. Because of the small size of the nanobody, it makes this molecule easier to produce in the E. coli expression system and make this molecule cheaper than the production of the whole molecule of the antibody. For the screening technique, we use the combination of the two techniques. Firstly, we use the yeast display technique to screen the yeast library that we derived from the Harvard University. And the second technique, we use the fly tap technique. Briefly, this is the technique that we develop inside our own lab. The SS-TOA will conjugate with the nanobody, and the PCSK9 conjugate with the beta-lactamase. If the nanobody from the library can bind with the PCSK9 molecule, it will be generate complex, the SS-TOA, nanobody, PCSK9, and the beta-lactamase. And the complex of the four molecules will be moved from the cytoplasm to the polyplasm and make the E. coli cell that contain the specific nanobody. Again, the PCSK9 generate the antibiotic resistant properties. So on the other hand, we can say that if the E. coli cell show the high resistance, we can get the high affinity of the nanobody molecule. And here is our result from the selection. The reference is mean the group of the E. coli that contain non-specific nanobody. They are completely suppressed by the carbenicin at the 50 microgram per ml, while the clone that contain the nanobody specific with the PCSK9 molecule can grow better, especially clone C10, C11, and C15 can grow at the 300 microgram per ml. After that, we construct the nanobody fragment into the PET28A vector and transform them into the BL21DE3 and use nickel NTA column chromatography in order to purify the nanobody for the next investigation. For the next step, we use the purified nanobody from the previous experiment to test the specificity against the PCSK9 molecule by using the ELISA technique. Firstly, we coat the PCSK9 inside the 96 well plate of the ELISA plate and then incubate with the nanobody. And we found that the clone T15, T21, and T22 can bind with the PCSK9 strongly. And not just only the wild type PCSK9, we also test the specificity against the D374Y PCSK9 or the gain of function type of the PCSK9. The clone T15, T21, and T22 also show the good binding against the mutation type of the PCSK9. And after our experiment and after this project, I think I could get the prototype of the nanobody that's specific with the PCSK9 and inhibit the PCSK9 and LDLR interaction to suppress the LDLR degradation and apply for dyslipidemia treatment in the future. Thank you.